Now that we've reviewed how to combine like terms, we want to explore just a little bit of what a polynomial function is, since we're going to be working with these functions for both Chapter 6 and Chapter 7. So a polynomial function is any function that's of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1, and so on all the way down to a0, which is a constant. Now, that sounds really complicated, but it really isn't. What it's saying is you have some coefficient, the nth coefficient, times x to the n power, so like x to the fourth. And then you have another one, and then that's x to the third. And then you'll have a next one, and that'll be x to the second, and so on. And you'll work your way down to the last term, which doesn't have an x on it, so it must be constant. It never changes no matter what the variable is. Okay? Now, the most important one to us is a quadratic. Now, a quadratic function is a polynomial function that's of degree 2. So its standard form is ax squared plus bx plus c, where obviously a cannot be 0, because if a was 0, then it would be a linear function. Bx plus c on its own is like mx plus b, right? It's linear. Okay, so let's take a look at what the basic polynomial, or excuse me, quadratic function looks like. Let's graph f of x equals x squared by hand. All right, so we can start off with, we know that 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. What about the negative values? If you take negative 1 and you square it, what will happen? Hold on. There it is. Negative 1 squared. When you square a negative, it turns it positive, right? So it'll become positive 1. Same thing will happen with negative 2 squared. Negative 2 squared become positive 4, and so on. So this will be positive 16. This will be positive 9. So when we graph these points, we'll form a curve. So let's graph those. And there it is. You can see it forms this classic shape, which is called a parabola. See that? Now, if you wanted to double check yourself or use your calculator to help yourself, you could, let's see here, go to y equals, clear out your old equation, and type x, and you'll have to use a little caret button over here, caret 2. Now, in the new calculators or in the new operating system, it'll make it look like a power, like that, but the old operating system on an 83 will not. So there we have that. And then if I want to make the window match the window we had on the screen, I could make my window go from, oh, now I don't remember, I think it was negative 6 to 6. Negative 6 to 6, negative 6 to 18. So I can go to window and say negative 6, 6, and then go down to the y min and make that negative 6, and then 18. And then I can press graph and see it matches the one that we have on the paper. And then also we can check our table by going to second table, and you can see the values in here. 16, 9, 4, 1, and so on. Okay, so that's a basic quadratic function. Makes a parabola shape, very important to us. We'll be coming back to that idea later in the chapter, and in chapter 7 as well. We're also going to look just real briefly at what a cubic function looks like. Cubic functions are degree 3, so the highest variable power you'll have is 3. All right, well, again, 0 cubed is 0. Sorry. 1 cubed is 1. 2 to the third would be 8, right? Because 2 times 2 times 2. 3 to the third is 27. But this is a little bit different than the other one. When you take a negative power and you raise it to an odd power, or just mean negative number raised to an odd power, that's still negative, right? So this is negative 1. Negative 2 cubed would be negative 8 and negative 27. Now, if I want to double check myself, I can grab the calculator, clear this, and type x to the third power, enter, and go to my table and double check. And sure enough, I'm right. There's negative 27, negative 8, negative 1, and so on. Okay, so now we want to graph this graph right here. And if you want to graph it on the same window on your calculator, you could go here, say negative 4 to 4, and then it was negative 28 to 28. But something interesting, I did not make actually every tick mark be worth something on the grid, if you look back at the graph. So I'm skipping, so it goes 2, 4, 6, 8. So I can make this x, or the y scale, excuse me, worth 2, and I will do that. and then press graph, and I get this general shape. Okay, that's a general cubic function. All right, so let me go graph that on our paper. And there it is. Beautiful. Okay, so now we know the basic functions. What's next? Oh, we're going to have to find and simplify some. All right, so let's see, f of 4. So you can see f of x was given as 3x minus 4. So when you want f of 4, you're going to take 4 and put it into that function. 3 times 4, take away 4, which is 12, take away 4, which is 8. So that's a little review. We already learned how to do that way back in chapter 2. Same thing with g of negative 2, but it'll be a little bit more complicated because it's negative. So g of negative 2 would be equal to negative 2 in parentheses squared, because you want to square all of negative 2, minus 2, or excuse me, minus a negative 2, minus 5. Now be careful. When you substitute with a negative, it is really useful to put in parentheses. Matter of fact, I'll make a note of that right here. Note. When substituting a negative value, always use parentheses. I don't say that for my health. I'm saying that to keep you from making mistakes, right? So always, always, always use parentheses when you're substituting a negative value. So you put negative parentheses, or parentheses around this negative 2 and parentheses around this negative 2. All right, so negative 2 parentheses squared is positive 4 because it's negative 2 times negative 2. Minus a minus 2 is plus 2 minus 5. So that's 6 take away 5, which is 1. So that's our result there. Okay, so now what about f plus g of x? Well, remember that's a notation thing. That means f of x plus g of x. It's just a faster way to write it. So what I really want is 3x minus 4 plus, and then the g of x, x squared minus x minus 5. Okay, well, obviously, in this particular problem, the parentheses are just kind of a fake. They're not really needed to be there. I'm just saying that I want this function in parentheses plus this function in parentheses. So I could just write it all out again. So I could say it's 3x minus 4 plus x squared minus x minus 5. And then I'm going to combine like terms. So I have x squared in front, because we always like our highest power in front. Then you have a 3x here and a minus x here. So those two kind of go together. Here, let me give them a little note. There, those two go together and make 2x. And then the two numbers go together. Minus 4 minus 5 makes minus 9. So x squared plus 2x, take away 9. Done with that. Okay, so now what about f minus g of 1? Okay, well, we could do this very similar to the last one, and I'm going to just to give you some practice with it. So I'm going to first find f of x minus g of x, and then I'm going to substitute 1 into it. So f of x take away g of x is 3x minus 4 take away x squared minus x minus 5. Like that. So I want 3x minus 4 minus x squared. You got to minus your minus x. So you have to distribute your negative. So plus x plus 5. So make a note. Distribute negative. And again, we're going to combine like terms here. So we're going to have 3x, or excuse me, negative x squared, because that's the front. So negative x squared. You have a 3x and another x, so that makes 4x. And then a minus 4 plus 5 makes plus 1. Okay, so there's f of x minus g of x, which technically they did not ask for, but I find it's helpful to remind ourselves how to find all that stuff. Okay, now we actually want to find what we were looking for, which was f minus g of 1. So what that is that's f of 1 take away g of 1. In other words, it's negative 1 squared plus 4 times 1. Oops, that's a plus sign. sorry, plus 4 times 1 plus 1. So that'd be negative 1 plus 5. So that'd be 4. And there's our final result. So again, we didn't really, there is another way to do this problem, but I wanted to show you guys how to do this by finding f of x minus g of x. That's important. And then we'll take 1 and plug it into that function, which we did. All right, so now we just have to do this little problem back here. All right, the revenue and costs, both in millions of dollars for Southwest Airlines at T years since 2000, can be modeled by the respective functions. R of t equals 183t squared minus 581t plus 5964, and C of t equals 102t squared minus 100t plus 4897. All right, so revenue. Revenue is the money you take in. Like when you sell stuff, that's your revenue. And then your costs and the money you're spending out. So we're going to find an equation for profit, which is your revenue take away your cost. So I've already started it here. You're going to have your revenue function, and you're going to take away your cost function. Okay, so this is equal to 1, and now I got to go write these out. It was 183t squared minus 581t plus 5964. And we'll take away my cost function, which is 81t squared minus 481t, excuse me, minus 100, plus 100t. My goodness, I'm losing my mind. Where is that cost function? Oh, there it is. I'm doing it all wrong. Sorry. There we go. Plus minus 102t squared. There we go. 102t squared minus 100t plus 4897. Okay, so we're going to have to distribute that negative. So that's our next step. So it's 183t squared minus 581t plus 5964. Take away 102t squared plus 100t, right? Because minus a minus 100 minus 4897. All right, now here's the 81. I was jumping the gun here. 183 take away 102 is 81. So it's 81t squared. Minus 581 plus 100 is minus 481t. Plus 5964 take away 4897. That's 1067. Just grab a calculator and you can find it. All right, so there's your profit function right here. This is R minus C of t, i.e. your profit. Okay, so now we're going to take that function and find what it is for when t equals 10. So let me go grab this. And I really only need this bottom part here. Okay, so we're going to take 10 and put it in here. And then 10 goes here, and 10 goes here. And then we're going to make a calculator find this, right? So let's see. I want to quit and get out of here. I want 81 times 10 squared. Move to the right. Minus 481 times 10. Or if you like, put parentheses if you so desire. Parentheses 10. And then plus 1067. Enter. And we get 4357. All right. So now we have that found. Then the question is, what does it mean? There we go. I had to type that up quickly. So in 2010, Southwest Airlines made about $4,357 billion, so $4,357 billion in profit, which would be $4.357 trillion in profit. All right, we're all done with that section.